Let's just take a look at how I visualize the digital value chain. This slide is my visualization of that process. So as with everything, the digital thread starts with an original idea. The idea is converted to data at the point of design. You can see that at step 1. That data is refined and evolved into a digital product or digital twin during the development phase, step 2. And by now I think that everyone sees the benefit of additive manufacturing during the design and development phase of the product lifecycle. The freedom of design and speed to market advantages are well documented and pretty obvious. I think there's a lot of things that have been written on those 2 first steps. But of course it doesn't end there. At step 3, now clever designers optimize the data for production. At this point, commercial imperatives kick in and production paths may diverge depending on the cost considerations. It may be better to produce a simple, high-volume, low-cost part by traditional manufacturing methods, such as, say, injection molding or subtractive machining, whereas a complex, low-volume, high-value parts might be produced additively. If the part is indeed produced additively, then there are several supply chain benefits that can be realized through step 4. Furthermore, every high-volume product has a low-volume phase-out period, step 5. With a well-thought-out approach to the optimization of the entire product life cycle, the benefits of digitization and additive manufacturing can again be realized as the product reaches the end of its effective life, the so-called digital inventory. Additive manufacturing is leading the way in the digital transformation. It's one of the purest digital technologies because it doesn't require tooling and fixturing, thereby eliminating or reducing those switching costs in moving a file to different locations and printers. That's a radical departure from the labor-intensive methods employed by the manufacturing industry for, well, over the last 200 years. In fact, the most disruptive aspect of additive has little to do with the actual printers. It's the conversion of a digital form into a physical good, meaning a file that has a representation of the final product that you want. Digital manufacturing can advance value at every step of the product lifecycle, and 3D printing is an important first step on the journey to digital transformation. Additive manufacturing allows for easy scalability from prototype to full-scale manufacturing. After all, prototyping without the vision and expertise to go into full-scale production misses the point of what additive stands to deliver. Applied intelligently, additive manufacturing can deliver a more efficient entire product lifecycle optimization. Additive may be seen as the perfect fit for low to mid-volume production, but with the right level of planning, engineering, and material development, a part developed using additive may also seamlessly transition into higher rate production. Equipment such as the aforementioned injection molding, casting, stamping, etc. Producing a part on demand with 3D printing enables manufacturers to print parts as needed instead of pulling the part from a supply warehouse. On-demand production helps companies realize huge reductions in inventory and storage costs.
Thanks for watching this video. If you liked it, please give it a thumb up. And if you'd like to have further information about educational content or other webinars from EOS, just click the links in the description box below. We hope to see you soon in one of our next videos. Until then, go and subscribe our channel. Bye!